everyone, Simi here. I'm excited to announce an upcoming multi-agent-based development course for senior GenAI folks, led by the brilliant Abhinash Mishra.
Hey everyone, and welcome. Today we're diving into something super important, building a safety net. You know, a process that makes sure the code you've worked so hard on isn't just done, but that it's actually ready for your users. Let's build our very first acceptance pipeline. You know the feeling, right? We've all been there. You've just finished a feature, all the tests are green on your laptop, but then that little knot of anxiety tightens in your stomach right before you hit the deploy button. You're asking yourself, is this really going to work out there in the real world? Well, that's the exact question we're going to tackle today. So how do we get rid of that deployment day anxiety? The answer is something called an acceptance pipeline. The best way to think about it is like an automated quality control gate. It's this series of checks that confirms your app doesn't just work the way it's supposed to, but that it also performs well under pressure. And it does all of this before a single user ever lays eyes on it. Okay, so let's break this whole thing down. Every good pipeline, has to start with the most basic question you can ask. Does this thing even work? And that, my friends, is phase 1, functional testing. The goal here is super simple. We're just laser focused on the core logic. We're not worried about speed or anything fancy just yet. All we need to know is when a user clicks a button, does the app do what it's supposed to do? This is our first line of defense, our wall against bugs escaping into the wild. So what does this actually look like in practice? Well, let's imagine we're testing a personal banking API. A functional test might automatically hit the login endpoint. Maybe it runs a quick MVN test command, and it's just checking one thing. Does it return the correct JSON with the right account balance? It's simple, it's clean, and it's absolutely essential. All right, awesome. So our code works, we've checked that box. But that just leads us to the next really important question. Okay, it works, but does it work when things get busy? Does it work under pressure? And that brings us to phase 2, performance testing. You know, a slow app can be just as frustrating as a broken one, right? I mean, we've all rage quit a website because it was taking forever to load. The goal here is to make sure our users get a fast, smooth, responsive experience, even if thousands of them are all using the app at the exact same time. Honestly, this is what keeps people happy and what makes them want to come back. So how in the world do we do that? We use some really cool tools that let us simulate the real world. For example, we could write a script, maybe something like a locusfile.py, that basically describes what a normal user would do. Log in, browse, add to cart, you name it. And then we just unleash thousands of these virtual users on our application all at once. It's how we find those performance bottlenecks before our real users ever have to suffer through them. Okay, so we have functional tests, we have performance tests. Now, you could run these by hand every time, and that's a decent start. But the real magic, the professional way to do this, is to automate the entire process. And that is where the whole concept of pipeline as code comes into play. I mean, sure, you could click around in a user interface to set up all your jobs and tests, but let's be real. The modern professional standard is to define your entire pipeline as code, and it lives right there alongside your application code in the same repository. And for a lot of teams using Jenkins, the engine that drives this whole thing is one single really powerful file, the Jenkins file. Just think of it like the master blueprint for your entire quality and deployment process. It defines every single step from start to finish. In doing it this way, it is a total game changer. Why? Well, first, it's automated. No more pushing buttons by hand. It's repeatable, so the same exact process runs every single time, no exceptions. It's scalable, so you can easily apply it to new projects. And crucially, it's version controlled. Your pipeline lives with your code, so you have a perfect history of every single change you've ever made to your deployment process. It's just better. Now, this next part is a really crucial idea to get. The logic of the pipeline, the whole build, test, deploy pattern, that's universal. The tools might be different, sure. You might be using MVNW for a Java project or PyTest for a Python one, but the fundamental stages, the core goals, they stay exactly the same. Okay, so we've got all the pieces. Let's put them all together now. We're going to take our functional testing phase and our performance testing phase, and we're going to stitch them into one seamless, fully automated workflow. This is the whole shebang. So here's how the whole thing flows from start to finish. Step 1, the pipeline automatically runs our functional tests. Does it even work? If all those pass, great. It automatically deploys the code to a staging or test environment.
Step 3, it unleashes our performance tests on that staging server. Is it fast enough? And finally, there's a manual approval gate. It just pauses and waits for a real person to give the final thumbs up before it goes out to production.
So let's recap the key takeaways here. At its heart, an acceptance pipeline is your automated quality gate. It's this powerful combination of functional testing, does it work, and performance testing, is it fast? And remember, using pipeline as code with something like a Jenkins file is the modern, professional way to do it. It's how you verify that your application is solid in a real, deployed environment before it ever gets to your users. Look, by automating this critical safety net, you and your team are freed from that fear of deployment. You get back time and mental energy to focus on what actually matters, building great things. So really, the only question left is, with that kind of confidence, what are you going to build next?
Folks, I hope you are liking our content and it is adding up nicely in your skill set database. If so, hit the like and subscribe button.
Welcome. Have you ever wondered how a massive, super regulated company like a global bank builds all its tech in the cloud without everything just falling into chaos? Well, today we're going to peel back the curtain. We're using a real playbook from inside Fidelity International to see exactly how they pull it off. Okay, so let's just dive right into the heart of the problem, right? As more and more companies are rushing to the cloud, they get all this incredible power, but they also get an explosion of complexity. So the real question is, how do you manage all of it? You know, the first step is to really get your head around the shift in how we build things. The whole nature of cloud technology creates a brand new set of problems that, frankly, the old ways of working just can't handle.
Now, what's really fascinating here is the contrast. The old way, think about it. It was all about someone manually clicking through web pages to set things up. It was slow, it was inconsistent, and it was so prone to human error. But the new way, it treats your infrastructure, all your servers, your databases, your networks, it treats it just like software. It's all defined in code, which makes everything fast, automated, repeatable, and, most importantly, safe.
So how do you actually make that jump from all those manual clicks to automated code? Well, it takes a really powerful shift in thinking. You have to stop building things by hand and start designing them with a master blueprint. And that blueprint has a name. It's called Infrastructure as Code, or IaC for short. The best way to think about it is like this. Instead of a team of people following some 100-step checklist to set up a server, you just write a single file that defines exactly what that server should look like. Then, an automated tool reads that blueprint and builds it for you, perfectly, every single time. And this right here, this quote pulled straight from Fidelity's own training material, it just nails the goal. It's not just about building something once, it's about being able to change and version your infrastructure safely and efficiently. Just like you can roll back a software update when something goes wrong, you can now do the exact same thing with your entire infrastructure. Okay, so having a blueprint is great, but you need a master builder, right? Someone or something to read that plan and actually construct the building. In the world of infrastructure as code, one of the most popular tools for that job is called Terraform. And Terraform works on this beautifully simple and totally predictable three-step flow. First, you write the code that describes what you want. Next, and this is the magic part, you run a plan. Terraform shows you a preview saying, hey, here is exactly what I'm going to create, change, or destroy. No surprises. And finally, if you like what you see, you apply it, and Terraform just makes it happen. So Terraform is our master builder. But how does a huge organization like Fidelity use it to manage thousands of projects all at once? You can't have every single developer writing super complex infrastructure code from scratch. You need a system. You could do it the hard way. For every database, every application, a developer could sit down and write hundreds of lines of really detailed code, figuring out all the networking, security, and compliance stuff from the ground up. Honestly, it's slow, it's repetitive, and it's just a recipe for inconsistency. Or you could do it the smart way. And this is what Fidelity's playbook shows us. They create what they call inner-source modules. Just think of these as prefabricated, pre-approved Lego blocks. A central team of experts builds a totally secure, compliant, and efficient database block. And then any developer in the entire company can just grab it and use it. Just look at the difference here. On the left, you've got that raw configuration, every single little detail spelled out. It's complicated, and it's easy to get something wrong. But on the right, that's the smart way. A developer just calls that shared Lego block, the module, and gives it a couple of simple inputs, like the database name. And here's the crucial part. All the hard stuff, all the complexity with security, logging, backups, it's all handled for them, hidden away inside that reusable block.
So what does all this mean for the average developer? You know, the person who's just trying to build their app. What's the real, honest-to-goodness payoff from having a system this sophisticated?
So inside Fidelity's training, they actually put this whole thing to the test. They give their Java and Python developers a little mini project. Take a simple banking API and just deploy it to the cloud using these pre-built modules. The whole point isn't to make them write complex infrastructure code. It's to see how easy it is to just use the finished Lego blocks. And get this, here's the result. Under 60 minutes. Let that sink in. They went from having application code on their laptop to a fully functioning, secure, and compliant service running live in the cloud. A process that used to take weeks or, let's be real, sometimes months of back and forth between teams is now done in less time than it takes to watch a movie. That is the incredible power of this system.
And this brings us to the big takeaway here, not just for banks, but really for anyone out there building software today. This systematic approach to infrastructure, it's so much more than just a little process improvement. You see, when you get this right, infrastructure stops being a bottleneck. It's no longer this thing that developers are always waiting for. Instead, it becomes a self-service superpower, giving them the ability to innovate and deliver value to customers faster and more safely than they ever could before.
So as we wrap this up, the playbook from Fidelity really leaves us with one critical question that we should all be asking our own teams. Is your infrastructure unlocking innovation, or is it the thing that's slowing it all down?
Folks, I hope you are liking our content and it is adding up nicely in your skill set database. If so, hit the like and subscribe button.